So 1.7, essentially what they're getting at here is the unit circle. That should really be the title of this. We're looking at being able to evaluate a trig function for any of our common angles, okay? And there's really two keys, I guess three components. You have to be able to identify the reference angle. That's first and foremost. You got to be able to find the angle and its reference angle, and that's why they have us practice that here. You then need to know quadrant 1 of the unit circle, which we've drawn a few times already and will continue to do. And you need to know all students take calculus. And the three of those pieces together make it so you could rapid fire answer, you know, sine of 210, cosine of 330, any sine or cosine or any trig function for a common angle. So let's just make sure we're okay with the idea of reference angles first, okay? So again, we've been using this a lot, and then it's only now that it's officially being defined. I'm just going to redraw what they're showing because their picture's not that big, but they're drawing, I think in that diagram, a 150-degree angle. Everyone just needs to be comfortable with the idea that your reference angle is the quickest way to get to the x-axis. No matter where you're at, you either go up or you go down. It's the fastest way to the x-axis. So in this case, it's 30 because the main angle is 150. The other thing to mention or remember is it's always positive. Doesn't matter which way you're going, up or down. We always treat it as positive because we think of it like a distance. Yes, very good catch. 150 and 30 add up to 180. So this first little bit is just making sure that you can find a reference angle. So let's just do a couple of these. They give us an angle, theta is 330. Now it says sketch the angle and its reference angle and identify them in both radians and degrees. Well, radians we don't get to till chapter 2. So let's not worry about that, just degrees. Angle 330. So I would go all the way around, almost all the way around the circle. We'd cut it shy. There's 330, right? What would you say is the reference angle there? Let's make sure we're all okay. Theta prime, what would be my reference angle?
30 degrees.
30. So that's the first key step to being able to do these is make sure you can get the reference angle. Let's do B together and just make sure we're all good, although I think we've got the idea. 135 would be here. So if that's angle theta, my reference angle would be this distance. And again, we call it theta prime, or a lot of books do. Is everyone picking up okay that that distance would be 45? It's just the quickest way to the x-axis, up or down. See, there's two ways to the x-axis. I can go straight at it, or I can go the long way. You want the fastest way, which is straight at it, up or down. And negative angles, they have reference angles too. So let's go ahead and do the obnoxious one, the negative 960. It's a little overkill for the practice we need, but let's just run with it. Remember, negative does not mean that we move clockwise. Yeah. Why is it called theta prime? In math, well, they're both variables. So frankly, you can call one Chuck and the other Larry. It doesn't matter. But you couldn't call them both theta because that would imply that they're the exact same thing. So we like to use theta to show that it's related to the other thing, but the prime symbol just distinguishes it as being different from your original angle. So it's just a common way to label a reference angle is to use the same name like alpha, beta, or theta, but to add the prime to it. Again, just to show that it's paired with this guy or belongs to this guy, but it's not identical. Yeah. So let's see, negative 960. So starting in standard position, I'm going to spin clockwise. Let's see, there's negative 360. That's one lap. Another full lap would be negative 720. Okay. If I did another lap, I'd be at negative 1080. That's too far. So I'm at negative 720. Let's go half of a circle. 720 and 180 brings me to negative 900. And then 60 more. It's pretty obnoxious. Another way to do it would be to find something coterminal. Couldn't I just like add 360 to that number until I get an angle that I can quickly point to, that I'm more familiar with? That you're certainly allowed to do that. However you do it, the goal is to identify the reference angle. And I don't know if you heard it when I was counting it out, but that would be 60 degrees off the deck there. That would be my reference angle. So that's key number one, find the reference angle. Key number two, and we've talked about this already, so we won't go into it in exhaustive detail, but remember the trick that all students take calculus. And this is just a quick way to remember which trig functions are positive and in which quadrants. In quadrant one, all trig functions are positive. In quadrant two, sine is positive. And it's, reciprocal. In quadrant three, it's tangent that's positive. And in quadrant four, it's cosine that's positive. And everybody else is negative by default then, okay? So these are two of the three key components we need to be able to rapid fire use the unit circle, which is what we're going to do on the next page. So let's take a look at that. Actually, on the next page, I think they begin with a little more in-depth look at, this is what they're telling you is all students take calculus. But see, they're actually showing you every single function and when it's positive or negative. They're using red. So anything that's highlighted red here is greater than 0 and it's positive. And you could see that in quadrant 1, everybody is positive. In quadrant 2, just sine is positive. And it's reciprocal. But again, what's true for sine is always true for cosecant. Quadrant 3, it's tangent. In quadrant 4, it's cosine. That's positive. So you could remember them that way, but I certainly think it's easier just to remember all students take calculus. Okay. One other thing in the notes that we're hopefully going to avoid is, it's weird. When I download the notes and then try to put them into OneNote, every time there's a trig function written, every time there's a sine, cosine, or tangent written, it doubles up every freaking time. And it's, you can imagine in a trig course, there's 1,000 of these. So I go through and I delete them. I clean them up, but apparently I missed one. So if you see this, don't panic thinking like, what the hell is sine? It's a typo. It should just be sine of 30 or 300. So I'll try to get all of those, but clearly I'm going to miss some. That's one of the reasons, like, why I say don't print ahead too many notes ahead. Okay. By the way, chapter 2 is good. Chapter 2, I freshened up. You could print chapter 2 notes up and we'll need them for class on Thursday. But let's go ahead and evaluate these using our unit circle. So I'm going to add that picture here. Because again, I've got basically two methods. One is draw the triangle, draw the special triangles in there, the 30, 60, 90 or whatever it is, and SOHCAHTOA your way out of there, like we did on the last in 1.6, and it works. It's just a little longer. It's going to be a little more effective to think of your unit circle. Again, we're listing our cosine values and our sine values. And so these you do want to have memorized. It's one of the few things I'll say memorize in math, because really in this course you don't want to memorize much. You want to be able to dig your way out of trouble. But this makes it so much faster that it's worth it. So I don't know, just by habit, I always draw all of quadrant 1. That should become automatic for you. So redraw that thing as many times over and over and over, as many times as you need to where you're on autopilot. And so let's go through the steps together. This is not the only way to do these problems, but after years of experience, I do think this is the most effective way. Draw angle 300 degrees and establish the reference angle. So 300 would be out here-ish. More importantly is, what is the reference angle? That's what I need. So is everyone okay that reference angle would be 60? So step 1 done, get the reference angle. Once you know the reference angle, you're basically there. If I want sine of 300 degrees, as soon as I figure out that my reference angle is 60, that means look at 60 degrees on your unit circle, and what is sine? Rad 3 over 2. So without a doubt, this thing is a rad 3 over 2, for sure. but it might be positive, it might be negative. That's where all students take calculus helps us square that away really quickly. In quadrant 4, only cosine should be positive because of the C. Everybody else should be negative. So that means a sine is a negative rad 3 over 2 there. And that is the fastest way to do these. Again, you're more than welcome to, draw that right triangle. And if that's 60 and that's 30, then this is A, and this would be negative A rad 3 because it's going down. You could do this, but that's just more involved. So I would just encourage you, if you don't already have a routine or a rhythm or some way of doing this, I would encourage you to try and practice my way of doing it. Not that you have to, but I've found that I think it's the most painless once you get it down. So let's try the next one, but stop me if you got a question. Cosine of 225. So again, step 1 is let's find that reference angle. So there's 225. Hopefully everyone's feeling okay that would have a reference angle of 45. And right there, I've got almost the whole problem done because I know now that cosine of 225, it's the same size slice as a 45-degree slice. So I'm just going to consult my 45-degree slices over here. And I'm asked to find cosine. That's the x value there. So without a doubt, the answer is a rad 2 over 2. Maybe positive, maybe negative. That's where I'm going to ask all students take calculus for help. In quadrant 3, it says only tangent should be positive. So anything else should be negative. I hope that's feeling all right. Let me know if there's any issues, but I'm thinking that's hopefully okay. Try cosine of 330. If you haven't done it yet, try cosine of 330. Any way you want to do it, but I would encourage you to go about it this way. If you, like I said, if you don't already have a method you prefer. Draw the thing, establish the reference angle, consult your unit circle, and then get your sign correct. Let's see, is everyone okay that my reference angle is 30? I'm hoping. Let me know if any clarification needed. And so again, the second I see that, oh, my reference angle is 30, it means that I'm just looking at this branch. And I want cosine, well, that's the x value, right? So I know this is, without a doubt, this is a rad 3 over 2. I know that. The question is just, is it positive or negative rad 3 over 2? That's just the last piece to figure out. All students take calculus. In quadrant 4, cosine is positive, and so since I'm after cosine, this is where we should leave it positive. All right. Is that okay? Or any questions on doing that? Let me know if there's anything I can help with.
So what's stopping us from having 1/2 as our answer?
Because 1/2 would be the sine value. Good question.
Oh, okay.
Right? So whenever you're reading those ordered pairs, the cosine is the x value, the sine is the y value. So can you guys just try, what about sine of 330? Let's just add one to the mix here. What is sine of 330? Very close, Jasmine. It would be negative 1/2, right? Exactly. So just using the same picture, it's always a sine, don't worry. But using the same picture, my reference angle is 30. So that means, again, look at the 30-degree angle on your chart and look for sine. It's 1/2. So without a doubt, it's 1/2, but don't forget to clarify this or to dig up the right plus or minus sign. Given that we're in quadrant 4, only the cosine is positive, which means everybody else is going to be negative. So it should be negative 1/2. But once you practice this enough, it really does become kind of automatic, and it becomes a really efficient way to find sine or cosine for any angle out there, or at least any angle that's made up of a 30, 45, or 60-degree reference angle. And those are the only ones we bother to memorize. So there's a couple more on the next page. It's the same thing. Let me go ahead and just jump to that next page and let's try those. Yeah, you don't need to do the whole circle. In fact, Brian, let's address that right now. You only need quadrant 1. And so let me just Actually, I think Hector mentioned something about symmetry, and this is where I was saying let's look at it. Let me fill in this picture because here's the unit circle, and if you look at there's two spots here for the angles because one is in radians, but let's just put in our degree measurements for our common angles here. Just quadrant 1 is all I'm going to mess with. Don't forget your degree symbols. Got to be there. And so the ordered pairs would be 1, 0. For 30 degrees, here's cosine and sine. For 45, there's cosine and sine. Now these I have memorized. If I forget, I can always go get them by drawing a 30, 60, 90 and actually using SOHCAHTOA to go find cosine of 60 or sine of 60. And just remember, they're in the format cosine is the x value and sine is the y value. So here's why you don't necessarily need the entire circle, as long as you are okay with all students take calculus. If you're good there, you're good. Because just hypothetically, let's say I was working on this angle, 150 here. That's 150. Well, I just recognize that, well, it's a 30-degree size slice, just like this guy is. They're the same slice of pizza, right? It's like it doesn't matter which of those slices you eat. They're the same size. They just came from different ends of the pizza. So you can envision that this pink triangle here is sort of, we can get that by taking the yellow triangle and just flipping it over the y-axis. Just flip it over. And when you reflect something over an axis, it doesn't expand or compress. It doesn't shrink or grow. It stays the exact same size. It's just your directions have changed. And so, in other words, if I had to go right radical 3 over 2 and up a half to get to that data point there, I'm going to need to go the same distance, but this time I'm going left a radical 3 over 2. That's why it's negative, and up a half. So it wouldn't be hard to fill out the rest of this circle, but it's just really not needed. I mean, that tells me that at 150, cosine of 150 is negative rad 3 over 2, and sine is 1/2. I didn't need that to do the problems beforehand, right? What I needed was all students take calculus. That's going to help me figure out what the sign should be. So it really isn't hard to populate this table because all you're doing is you're taking these slices and you're flipping them. And now that one's going to flip down. And so I can see the ordered pair that would land down there would be left and down. So it'd be negative for both pieces, but it wouldn't change size. It's the same distance, just different direct. What you need is you need quadrant 1. As long as you got that, you're golden. You're good. In addition to all students take calculus, I suppose. So let's just, again, try a couple more here. Sine of negative 45. Draw it and identify the reference angle. So negative 45 means I'm going clockwise. Wouldn't my reference angle be 45 degrees, right? That's the shortest way to the x-axis is 45-degree reference angle there. Which all that does for me is when I see that reference angle, I go, sweet. That means that I'm looking here. And I want sine. Remember, sine is the y value. So sine of 45 is definitely a rad 2 over 2, right? That's according to my unit circle. Sine at 45 is always rad 2 over 2. I do need to make sure I get the plus or minus right. So all students take calculus. In quadrant 4, the sign needs to be negative, doesn't it? So I got to add that in manually. But that's it. Unit circle, man. It really, once you get the procedure down and you're comfortable with it, it's an excellent tool. And it helps with these weird quadrantal angles, right? So if I want cosine of 90, well, I'm sorry, negative 90 would be down here, right? There's negative 90, if I can get it to right. If I'm on a unit circle, meaning I'm only allowed to walk 1 unit in either direction, what's that ordered pair there? That's this guy. What would that ordered pair be on the unit circle there? 0, -1. And so right There's my cosine value and there's my sine value. So I wanted cosine of negative 90. It's 0. Done. So let's go ahead and try the next one. Now on the next one here, if I'm looking for secant of negative 300 degrees, remember secant is 1 over cosine, right? So this is technically 1 over cosine of negative 300 degrees, meaning what I need to do is I just need to figure out what is that. I sort of need to come off to the side and figure out what's cosine of negative 300, and then I'll just reciprocate it to get the secant. So coming off down to the side, can you take a minute or whatever you need, find cosine of negative 300 using this procedure? Sketch the angle, find the reference angle, consult the unit circle, and then make sure you've got the right sign using all students take calculus. Remember, negative angles move clockwise, so don't get tripped up on where this one lives.
They all move clockwise, right?
When it's negative, yep.
All right.
So let's take a look here. Negative 300. Well, moving clockwise, it would be around there. Everyone okay that my reference angle would be 60? I'd be 60 degrees off the deck there. And so all the reference angle does is it tells you where to look at in your unit circle. It says, all right, look at the 60-degree stuff. And from there, pluck out your cosine value, which would be the x value. So cosine of 60 is a half. So cosine of negative 300 is a half. Do make sure that you have the correct plus or minus sign. So this would be all students take calculus. In quadrant 1, where that angle terminates, everybody's positive. Right? So cosine of negative 300 is a positive half, which means secant is 1 over a half, which becomes 2. Last page, let's see. Let's just jump right to the tangent of 840. You know what? I'm going to kind of jump ahead because tangent, if you notice, the unit circle doesn't quite help with tangent until we talk about something else, right? There's no tangents there. It's all cosines and sines. And so at the moment, the only real way to do tangent would be to draw the triangle, fill in the missing sides and use SOHCAHTOA. Like draw the special triangle, put in the A rad 3 and the 2A and do a SOHCAHTOA. But we can still use the unit circle, and here's how. So this is actually on the next section, but let's use it now. Look what happens if you take sine of an angle over cosine of an angle. And shoot, let's go ahead and just use what we know. Isn't sine opposite over hypotenuse? And isn't cosine adjacent over hypotenuse? So I'm just plugging in whatever the heck they would be. It'd be the opposite over the hypotenuse divided by the adjacent over hypotenuse. Well, remember how you divide fractions like this. Doesn't the first one stay the same? And you, instead of dividing by that other fraction, don't you multiply by the reciprocal of it? That gets these hypotenuse to cancel. And you're left with opposite over adjacent, which is tangent, right? TOA. So what we essentially proved is that tangent can be found by taking sine over cosine. So that's why the unit circle doesn't have any tangents on there, because you don't need them. All you need is cosine and sine, and you can get tangent by dividing them. And we're going to see that in trig in general, is that everything in trig can be broken down into plain old sines and cosines eventually. So if I had to do tangent of 840, I'm going to do the same method, but I'm going to go find what is my sine and my cosine of my reference angle there and divide them. So let's try that. And then let's do the calculator thing and get out of here. I'm going to skip D for now. So first of all, 840, we got to find that thing. 840. So if I go all the way around, there's 360. If I go all the way around again, there's 720. If I go from 720 and 180 is 900. So I overshot. I have to go back 60 degrees to get my angle. So I hope everyone kind of followed that. It's annoying when it's these big angles because you got to keep a running tally in your head. But 1 lap was 360, 2 laps was 720, half a lap on top of that. If you take 720 and add 180, you're at 900, and that was too far. So that's why I backtracked or gave back what's necessary to get to 840. In the process, I was able to find my reference angle of 60. All right, so if your reference angle is 60, that means, all right, consult your unit circle, which I'm just, instead of redrawing it, I'm going to go back to the previous page. At 60, there's my sine and cosine, or my cosine first and then sine. I got to be careful in the order. Right, so it's 60 degrees. Here's cosine, there's sine.
And that's how you write a tangent? You put both sine and cosine?
I'm going to divide them. So watch. So yeah, if I
Okay.
want tangent of 840, I'm getting ahead, but we're using this idea that tangent is the same as sine over cosine. So I'm going to take the sine, which is this guy, and divide it by the cosine, which is this guy. And now I need to be one more thing to pay attention to is watch out for the plus or minus signs. In this quadrant, all students take calculus. For where 840 terminated, it terminates in quadrant 2. So actually, you know what? Sorry, I'm going to come back and add one more thing here. Really what I'm doing is I'm writing, let me add this, sine of 840 over cosine of 840. Let me add that step in there. Now, sine of 840, we said was radical 3 over 2. Again, I'm just using my reference angle of 60. And in quadrant 2, is sine positive or negative? Like where this guy terminates.
Negative.
Right. In quadrant 2, sine should be positive. This dude is positive, right? But cosine is negative. So when it comes time to find cosine, I get a half. But because I'm in quadrant 2, only the sine should be positive. So it means this guy is negative. And overall, tangent is going to be negative. In fact, that's kind of the faster way I could have done it, is just saying, well, it's in quadrant 2, then my answer for tangent has to be negative. But regardless, if you were to set this up kind of like I did here, multiply by the reciprocal, or you could just cancel the 2's, you're going to see that I'm going to get a negative rad 3 over 1, or negative radical 3 for this answer. Frankly, I don't think we should even concern ourselves with worrying about those right now. We need to get good at getting cosine and sine for any angle. So the problems I would make sure you're okay with is like the ones we did on the last 2 pages, really. For any angle, can you find sine or cosine using this method? Find the reference angle, consult the unit circle, and then consult all students take calculus. One thing that's important to know how to do in trig is you got to be able to put things in your calculator, right? So, and angles are measured in 2 different types of modes, radian measurement and degree measurement. And right now we're using degree. Your calculator has to know that. So if your calculator's in the proper degree mode and you type in tangent of 50, I'm just going to give you the answer. You should be getting 1.192. And if you type in sine of 165, you should get 0.259 if I'm rounding them to 3 decimal places. Try that on your own.